Handling lists of values in shell scripts with separate variables collapses the moment your list grows beyond a handful of items. File 1, File 2, File 3, File 4. Every name must be tracked, passed, and iterated individually, and the moment one value contains a space or a special character, your logic fractures. Arrays solve this by treating a collection as a single, traversable unit. Indexed arrays are the default workhorse. Indices are zero-based integers. The array is declared implicitly when you assign, or explicitly with declare, a, and you can build one in a single shot with arr sadface alpha beta gamma, or grow it slot by slot with arr 0 equals alpha. Every element lives at a numeric position, which makes ordered iteration and positional access natural. Associative arrays replace integer indices with string keys, turning the array into a lookup table. They require declare, a and #for or newer. Without that declaration, assigning with a string key is a silent error. The syntax is declare, a map sadface host equals 10.0.0.1 port equals 8080, and you read values back with $map host. This is the structure you reach for when position does not matter, but the key does. Quoting is where arrays destroy unwary scripts. Unquoted $arr at word splits every element containing whitespace into multiple arguments, the classic silent bug. The fix is universal. Always expand as $arr at, with the double quotes intact. Then there is $arr**, which without quotes joins every element into a single string using the first character of IFS, often a space, silently merging your data. Quote that too. Empty arrays and unset variables look identical in tests, but behave differently when you reach for a default. $varr at fallback substitutes fallback when the array is unset or empty when referenced as $varr at. But if the array exists as empty, behavior shifts subtly with other expansions. The rule is simple. Declare your arrays up front with declare, a or declare, a, so the distinction never ambushes you. Choosing between indexed and associative comes down to one question. Does order matter? Or does the key matter? Indexed arrays are for ordered lists, file names in sequence, positional arguments, log lines, command output to iterate in order. Associative arrays are for lookup tables and config maps, environment settings, option to value mappings, counters keyed by a name. Mixing them up costs clarity, never correctness. The mental model that keeps this straight. Think of an indexed array as a row of numbered shelves where position is everything, and an associative array as a cabinet of labeled drawers where the label is everything. Numbered shelves preserve order for iteration. Labeled drawers enable direct lookup by name. Once you hold both pictures in your head, every bash array decision becomes obvious. Here is the side-by-side comparison. Indexed arrays use integer keys are declared with declare, a built with arr sadface abc, or arr 0 equals a, access with $0, iterated with $arr at, and exists since bash 2. Associative arrays use string keys, require declare. A are built with declare, a map sadface k equals v, access with $map k, iterated with $map at, and require #for or newer. Use index for ordered lists. Use associative for lookups and config. Bash lets you store lists of values in arrays, and you can mix indexed access by number with associative access by name. Before we start poking at arrays, a clean slate makes the output easy to read. First we declare an indexed array with 3 strings, then print the element at index 1. Bash arrays are 0 indexed, so slot 1 holds the second value, banana. Using at inside the braces expands to every element in the array, space separated. This is the standard idiom for printing an indexed array in full. Prepending hashtag to the array name returns its length, the count of elements, not characters. Here we confirm our array holds exactly 3 items. Associative arrays work the same way, except you declare them with declare, and you look values up by string key instead of by index. We build a small color map and pull out the value for the key red.